Welcome back. So now to start with our first concept being the components of an electric circuit. Remember, our main idea is still now looking at the parallel circuit. Now, what is a parallel circuit? Now, that's a circuit in which offers more than one way for the electrons to flow. So a parallel circuit is one which offers more than one pathway for the electrons to flow. So it's more than one pathway for the electrons to flow. Now, when we are constructing a parallel circuit, we say the components are going to be connected in parallel. Why? Because now there's going to be more than one way for these electrons to flow. So in a parallel circuit, as we have in this diagram here, when the electrons are moving, when they get to the junction here, some electrons are going to use this path, and the other electrons are going to use the other path. However, the number of the electrons that we find in this parallel circuit are still going to be the same throughout. They'll only be different when now they are going to split into the ones going into the first resistor and the other ones going into the second resistor. However, after having passed through these resistors, at this point, they're still going to add back together and be the same number that they were initially before they split. So we are saying that a parallel circuit offers more than one way for the current from the negative terminal to the positive terminal. So as your current are moving from the negative terminal, they are going to the positive terminal and continuing in that loop. So now, these wires are providing that path for the electrons to flow because they're in an electric circuit. So the electrons are going to be moving from the negative terminal, going through the wires. Once they get to this point, they're going to split. Some are going to now, let's say now, we have 2 amperes of current, or the electrons that are moving here. Once they get to this point, if these two resistors are identical, by that I mean if they have the same resistance, then that means the current is going to split equally. So that means here on the first wire we're going to have 1, and also on the second wire we're also going to have 1. So they're going to pass through this resistor, pass through the resistor, and once they get to this point again, they will add up again and add up to 2. So the one that was passing through the first wire and the one passing through the second wire will still add up again there to get back to the initial current that we started with. So we are saying again that there are 2 paths for the current in this parallel circuit that we are talking about here. We have path number 1 here and path number 2. So each of the current that we have, in this circuit will pass through each of the wires, and because the 2 resistors are identical, the same current will pass through in each resistor. So the same number of current will pass through each resistor. So now, in an electric circuit, you also find an ammeter. Now, an ammeter is now a measuring device used to measure the electric current. So this electric current, we are measuring it inside or in the electric circuit. So we do know that the current is measured in amperes or denoted by the capital letter A. And this is going to be our symbol for the ammeter in the electric circuit. So in a parallel circuit, you also find resistors. And remember, we're going to be using our light bulbs as our resistors. Now, what are resistors? So the resistors are said to resist the movement of electrons. So the resistors, they are resisting the movement of the electric charge or the electrons, hence the name resistor. They are resisting. They don't want the electrons to pass through, but then they do allow them to pass through. However, they don't make it easier for those electrons to pass through. So therefore, the resistors influence the electric current in a circuit. Remember, there is a relationship between the resistance and the current, right? So you're going to talk more about those in a parallel circuit, that what is the relationship of the resistance in relation to the current in this particular circuit. So resistance is measured in ohms, and it's symbolized by the Greek letter omega. So this is now the symbol for the resistance. Remember, we said current, it is measured in amperes, and the symbol for that is capital letter A, whereas now the resistance, it is measured in ohms, and the symbol for that is the omega, the sign that we have there. So there is the symbol for for resistance is omega, the sign that we have there. Then in an electric circuit, if you are drawing the electric circuit, the symbol for resistance that you're going to be using, or the symbol for a resistor that you need to draw in an electric circuit, should either be one of these two things, because both of them, they denote the resistance or the resistor of an electric circuit. We can either use the first one or we can use the second one to denote resistor in a circuit. Furthermore, in an electric circuit, or basically the main one, the parallel circuit, when we are adding more resistors in parallel, the total current strength increases. So remember we said you're going to look at the relationship between the resistance and the current. So this is that relationship, that when we're adding more resistors in parallel, so when we are adding more, like in this case, we have 1, 2, 3 resistors in parallel. So if we had only just one, if now we were to disregard these two resistors and only have just the one light bulb in our electric circuit, and then add another one, which is going to now make 2 light bulbs, and then add another one to make 3 light bulbs. So as we are adding an additional light bulb in an electric circuit, the current strength is going to be increasing. So what we need to note about this is that when we are adding the resistance in parallel, when we're adding another light bulb in parallel, we are basically decreasing the resistance of the entire circuit. So that means in parallel, when the resistance decreases, the current is going to be increasing. So the current will increase once the resistance is decreased. So basically what we're saying, by adding an additional resistor or by adding an additional light bulb in this electric circuit, we are decreasing the resistance. So overall, because we have added more resistors in parallel, overall the resistance of the circuit is going to decrease. And once the resistance decreases, the current will increase, because the relationship between those two components, resistance and the current, they have that relationship that when one increases, the other one must decrease. In this case, when the resistance decreases, the current is going to increase. In addition, the current in each light bulb is the same because all the bulbs glow with the same brightness. So the brightness on each of these bulbs is going to be the same. Now, this is assuming that the light bulbs, they all have the same resistance. So each of these light bulbs will have the same resistance, and that would then mean that the current passing through those light bulbs is going to be the same. So now when looking at the current coming from the cell, so the cell is going to supply the circuit with a current of 0.27 amperes. Now this current is going to divide into 3 equal parts. So some will go through the first light bulb, some will go through the second light bulb, and some will go through the third light bulb. However, when you add all of these currents that has split, remember that when it gets to this point, it needs to split. Some has to go there, some will have to go through there, and some will have to go through the third light bulb. However, when you're adding all of these currents that are passing through in each of these resistors, they still need to add up to the total current of the entire cell. So to the total current of the entire circuit. So we are not going to lose or gain more current. The current that we start with should be the current that we end up with once the current has circulated in the entire electric circuit. So this tells us that the current of the electrons splits up and moves through each branch. So the current is going to split and move through each of these branches. However, when we're adding all of those currents that have split, they still need to add up to the 0.72 amperes. Now, the cells that we remember that we have talked about the resistors in electric circuit. We talked about the ammeter in an electric circuit. Now we can also talk about the cells in this electric circuit. We can still now connect our cells in parallel. Remember, if it's one, it is a cell. But then if it's more than one, that makes up a battery. So these cells they can be connected in parallel. So when we are adding a cells in parallel, so if I were to add another cell there in parallel to the other ones, that has no overall effect on the current strength. So the current that is found within the electric circuit is not going to change if I add more cells in parallel. So the current will not be changed if I add more cells in this electric circuit. Remember, the relationship is going to be between the resistance and the current. That once the resistance decreases, it decreases in parallel if you add more resistors. In other words, if you add more light bulbs in parallel, the resistance is going to decrease. However, the current strength is going to increase because of that relationship. So we're saying that the current strength stays the same if you add cells in parallel. So you need to remember that resistance and current, they have that relationship that when one increases, the other one decreases. But then the current and the cells in parallel, they do not have, the adding more cells in parallel doesn't have any effect on the current strength. The current strength will remain the same even if you add more cells in parallel. Now, as we have said, there is more than one pathway for the current to flow as your current is moving from the battery or from the cell going through the entire circuit. It has to now split in all of these branches, as we can see. However, when it gets back to this point, after having passed through all of these resistors, when it gets back to this point, it still needs to sum up to the first current or to be the same current as the circuit had in the beginning when we connected the battery. So if the current was 5 amperes there, it will still be 5 amperes here because now it has added up together. However, in each of these branches, the current is going to be different from the 5. It is going to be smaller than the 5 because the 5 has to split in 3 ways. Some has to go through there, some has to go through the second branch, and the other ones will have to go through the third branch, as we have said. And then because these resistors are identical, they will all have the same brightness because the current that is passing through in all of them is going to be the same. We are then saying again, if we add more resistors in parallel, the total current supplied by the cell in the circuit is going to be increasing because of the relationship between the resistance and the current. So, as electrons approach the branch in the circuit, some electrons will take the first path, as we have said, and the others will take the other path. If you now look at this particular circuit diagram that we have here, now as your electrons are moving from the battery, now this is now a battery because there's more than one cell. As it is moving through the battery, this is the total current of the entire circuit, right? And then once it gets to this point, it has to split into two equal parts. So some will have to go through the first branch, as we are saying, and then the other one will have to go through the second branch. Now the current here that is going to pass through this let's call this bulb number 1 and bulb number 2. The current that is going to pass through bulb number 1 is going to be the same current that is going to be passing through bulb number 2. However, the current at bulb number 1 is going to be different from the current at A1, at the ammeter A1. However, the current now pass at A4. Now, after the two currents have passed through bulb number 1 and bulb number 2, they will add up together here and pass through A4. Now, the current passing through A4 is going to be equals to the current that was at A1, because what happens here, the current at A2 and the current at A3 are going to add up together and be equals to the initial current that the circuit had initially. So what we are saying here, this current, when it gets to this point, it is going to be divided into two pathways. However, those two pathways will each receive the same amount of current because the resistors that we have there, they are going to be identical, right? However, if the resistors were not identical, we're saying that once the resistance increases, the current is going to decrease. If the resistance at this particular bulb was, let's say, 6 ohms, and this one was 3 ohms, it would then mean that because the resistance at bulb number 1 is higher than the resistance at bulb number 2, the current passing through bulb number 1 is going to be lower than the current passing through at bulb number 2. Why? Because of the relationship between the resistance and current. Once the resistance increases, current is going to decrease. Higher resistance, lower current. Lower resistance, higher current. So that's what we mean. However, those two resistors, those two currents passing through those two resistors, they will still add up together here and be equals to the same current that the circuit started with initially. So in summary, what we're saying is, if these two bulbs are identical, the current at A1 is going to be equals to the current at A2. The current at A4. However, the current at A2 is going to be equals to the current at A3. Remember, if the two resistors are identical. What we're also saying is that the sum of these two resistors, or the sum of these two currents here at A1, when you're saying A2 plus A3, that is going to be equals to A1 and also going to be equals to A4. So A2 plus A3 is going to give us A1 and also A2 plus A3 is also going to be giving us A4. So that's what we're saying in summary. So before now going on to the next concept, let's quickly go for a short break and I will see you just after this.